Okay, so what are we looking at here? And pretty much most of you out there probably know what just the sine is or the cosine, but if you're taking trigonometry, you're going to have to deal with this, and we're talking about inverse trigonometric functions, and you do a ton of this, especially in more advanced trigonometry found in courses like pre-calculus. So if you're studying trigonometry, either by itself or within another course like pre-calculus, you're going to be running into a lot of inverse trigonometric functions type of problems. We're going to look at a few, and hopefully by the end of this video, you're going to really understand what inverse trigonometric functions are and why we need to know how to deal with them. And these problems, by the way, there's kind of multiple different flavors of problems that you have to know how to do. Sometimes you have to use your calculator, and other times you do a lot of problems without the aid of a calculator. We're going to look at both types here in this video. So anyways, I'm going to get to all of this in just one second, but first, let me quickly introduce myself. My name is John. I'm the founder of TabletClass Math. I'm also a middle and high school math teacher, and over several years, I've constructed what I like to believe is one of the best online math help programs there is. Of course, I'll let you be the judge of that. If you're interested, you can check out my math help program by following the link in the description of this video. But basically, you're going to find 100 plus different math courses, ranging from pre-algebra all the way up to pre-calculus, and I do a ton in the area of test preparation. So if you're studying for some sort of test, SAT, ACT, GED, ASVAB, AccuPlace, or ALEX, tons of different type of tests out there involve math. I have great test prep courses. I probably have the one that you're studying for, and I also do a lot with homeschooling. So if you homeschool, I have a great homeschool learning program. But and obviously help those of you who are having a tough time in your current math courses. Now, one of the things that I really stress is the importance of note taking. So if you're not taking great notes, you are doing yourself a major disservice in mathematics. So I can help you out with your notes. You can use my notes. Find a link to all this stuff in the description of this video. All right, let's get to it. What are we talking about here? We're talking about inverse trigonometric functions. So if you see something like this, we need to know how to deal with this little -1 up here. Now, this particular problem, okay, we would refer to this also as the arc sine. Okay, and of course, we have our main trigonometric functions, sine, cosine, and tangent. Anytime you see that little -1 up there, we're talking about the arc sine, arc cosine, arc tangent. Now, why do we need this? What's the value of this? Well, I'm going to walk you through a few different type of problems, okay, that really show the importance of inverse trigonometric functions. So let's start with a basic problem like this. Here is a lovely right triangle, and you can see the sides here are 3, 4, and 5. And let's say I wanted to find the angle here in this corner. This is the whole value of trigonometry. Okay, trigonometry is about finding angles. Trigonometry itself, the word is, the study of angles. So I'm like, okay, I'd like to find the angle here. I got the sides of this right triangle. So this is basic trigonometric ratios. So let's use the sine here. Okay, we can use sine, cosine, or tangent to answer this question, but let's just use sine as an example. So how do I use the sine? Well, you got to remember that phrase that you've learned, and hopefully you know this phrase, SOHCAHTOA. Now, if you haven't learned this phrase, you probably learned something similar to this, or you just have this in your rote memory. But SOHCAHTOA is just a little mnemonic that helps us remember the trigonometric ratios for those particular functions. So for example, sine, okay, we're talking about the sine, here is the ratio of the opposite over the hypotenuse. Okay, so OH, that's that's this part. So it's the opposite over the hypotenuse. Now, if I look at this right triangle, I have to look at where the angle's at. Okay, so what is the opposite length or the opposite side of this triangle? Well, this here is opposite, okay, of where the angle is located. This 4, okay, is the adjacent, so this would be the O. This would be the A, and the longest side of a right triangle is always the hypotenuse, H, okay? So, you need to understand this, and hopefully this is all basic review for you out there. Now, if you don't really understand this, you're definitely going to have a tough time dealing with more advanced inverse trigonometric function type of problems, but stick with me anyways. Hopefully this will all come together for you. All right, so let's talk about how to now find the angle here. Okay, well, we can use sine again. So sine is equal to the opposite over the hypotenuse. So the sine of this angle here, angle x, is its opposite. So that's 3. Okay, that's the opposite here again. And what is the hypotenuse? It is 5. So the sine of that angle x is equal to 3 over 5. And of course, I could divide that and have a decimal. Sine of this angle here, sine x is equal to 0.6. Okay, great, wonderful. How does this help us out? Well, it doesn't really help us out unless we have a calculator. Okay, we need a calculator. Or back in the good old school days, like myself, we're learning way back in the good old 1980s, we did have calculators, not as much. We had scientific calculators for sure, but they were kind of coming into play. But anyways, my point is we had big tables. The textbooks back then had tables of arc sine values and etc. But you need a calculator to find the actual answer here. Okay, so how do I find the answer? Well, we have to use the inverse trigonometric function. We need what we call the arc sine. Okay, so I'm dealing with the sine. I need the arc sine. Okay, which is an inverse trigonometric function. So that notation is sine with that little -1 up there. Okay, and what we're going to do, the arc sine is this. Okay, we're using this 0.6. We're going to find the arc sine of 0.6, and really it's just a question you're asking your calculator. You're saying, hey, tell me the angle that has a sine of 0.6. All right, that's what you're asking your calculator. Saying, tell me the angle that has a sine of 0.6. Now you can see that the answer, when you do this correctly, it's approximately 36.86 degrees. So this is the whole value of inverse trigonometric functions. Now, you're probably asking yourself, like, what is, what's this here? You wrote something down. And yes, I did, because I really wanted to give you a warning here, okay? So many students end up doing problems with the inverse trigonometric functions, and they typically will end up with a sad face because they'll do everything right, and then they'll get the wrong answer. And the reason why is because oftentimes you're going to work with radians. Okay, you'll work with radians. There's different ways to measure angles. You can measure an angle in either radians or degrees. Now, your calculator, you're going to be switching back and forth. If you're in a trig class, okay, you're going to be working with radians, working with degrees. So oftentimes, people will forget to switch the mode in their calculator back to degrees or radians or whatever the case is. Be very, very mindful of that if you're taking trigonometry. Always check your calculator first thing when you start plugging in values. Look at the mode, okay? Because it's so easy to forget. Oh, I left my calculator in radian mode or degree mode. You're going to be using both frequently, okay? So it's something that can happen, and you don't want to have a sad face. We want to get this right. All right, so this is the whole value of inverse trigonometric functions. Now, if you understand that, well, then let's move on and start talking about a little bit more sophisticated trigonometry. Okay, so let's take a look at a couple examples that you would find in like a pre-calculus course. And by the way, if you're interested in learning pre-calculus from me or need help with pre-calculus or trigonometry, you would want to check out my pre-calculus course. Okay, I teach everything in that course about trigonometry. But let's get into a problem like this. Pretty typical type of problem that you're going to find when you're studying inverse trigonometric functions. So it says find the sine, cosine, tangent given this point here, okay, -12.5, and -12.5 is on what we call the terminal side. And now we need to know a little bit about what we call the unit circle. So anytime you're measuring an angle in trigonometry, we have two sides. The x-axis, the positive x-axis here is what we call the initial side. Okay, then when we start measuring angles, we go from here and we measure like so, okay, then until we stop. Now where we stop, okay, like for this particular problem, we're going to stop where the array is going from the origin through that point. Okay, this is called the terminal side. Okay, that's the terminal side. This is the initial side, and angles, positive angles, are going to always go this way. Negative angles go this way. And hopefully this is kind of review for those of you who are taking trigonometry, right? You should already know this if you're studying inverse trigonometric functions. But the problem here is saying, okay, your terminal side is going through this point, -12.5, and let's find the sine, cosine, and tangent, okay? So how do I do that problem? Well, what we need to do is build ourselves a reference triangle. All right, let's get into this and you'll see exactly what I'm talking about. Okay, so here is our point, negative 12, 5. You can see our terminal side is going out to it. And I'm going to use this xy. Remember, this is x and this is y. We're going to build ourselves a nice reference triangle. Okay, and I'll explain the value of this here in a second. So y is 5, so that's positive 5 here. X is negative 12, and we absolutely need these negative values. Okay, you can see that we're talking about an angle that's ending in the second quadrant. Okay, this is the angle that we're talking about. All right, so we have 5, we have negative 12, and then I have 13 here. Now, I wasn't given 13, but what you're going to do is you're going to always go to the x-axis. You're going to draw a right triangle such that it's being formed with the x-axis. So you got 5, negative 12. In other words, you're not going to go this way. Right? A lot of students will make a mistake. They'll go like, okay, here's my point, negative 12, 5, and then they'll make a triangle like that. Okay, don't do that because you'll end up with a happy or a sad face, not a happy face. So, typical common mistakes, always go to the x-axis to make your reference triangle. All right, now, here we need the hypotenuse because remember, we're talking about SOHCAHTOA. We need the hypotenuse because we're dealing with the right triangle. I can use the Pythagorean theorem. You can see the lovely work here. So the hypotenuse is going to be 13. Now, when I take the square root of 169, you can see my work here. I'm using the sides. Of course, I'm kind of going quickly here to explain this, but the hypotenuse will always be positive. That's one thing that you want to remember because here, technically, this is positive negative 13, but this will always be positive. The hypotenuse will always be positive, okay? But your sides will be both positive and negative. That's extremely important because you'll get the signs wrong if you're doing this. Okay, so this is the setup. We got ourselves a nice, lovely reference triangle, but what do we do with it? Well, we need to kind of take it a step further. Okay, so we want to find the sine, cosine, and tangent of an angle, okay, such that its terminal side ends through negative 12, 5. So this is our angle, right? But here, I'm like, well, why did I make a reference triangle? I'm still looking for this angle. Well, the reference triangle, you can see I have an angle in here in blue. That angle, if I could find the sine, cosine, and tangent of this angle, it's the same as finding it as the actual angle. Okay, so the reference angle, okay, will give us the same answer as the actual angle. So you're like thinking, well, my angle goes like this. How am I going to get this correct? Well, remember, we build a reference triangle, and then we go to that reference angle in that reference triangle, and we're going to use our lovely SOHCAHTOA right here to just answer the question. Whoops, I didn't want to cross that out. We don't want to cross out SOHCAHTOA. We want to highlight it. Okay, so it's as simple as that. So let's just focus in on this reference angle, and we'll find, okay, the sine, cosine, and tangent. So the sine, again, is going to be the opposite over the hypotenuse. So if I look here very carefully, here's the reference angle. The opposite is 5, okay, and the hypotenuse is 13. That's positive, okay, so make sure that you have the right sign. Let's talk about cosine of that reference angle. It is the adjacent, which is negative 12, okay, over the hypotenuse, which is positive 13. So that's negative 12 over 13. And tangent is going to be the opposite, which is a positive 5, over the adjacent, which is negative 12. And this is the answer. Okay, so if you got this answer right, if you knew what to do, and you're like, yeah, I already know this, well, that's pretty good. Matter of fact, I might have to give you a 1984 head spin breakdancing style from like 1984, where we kind of like did crazy stuff. Everyone says, oh, this breakdancing stuff, this was, it's really cool. Some of these guys are amazing today. But yeah, we were trying. We were hitting, spinning our head. We were bored. We didn't have the internet back in those days, so we had to make things up like breakdancing. But anyways, great job. And now let's move on. Okay, we got to keep it light. We're talking about math. Let's try to have a little bit of fun while we're doing this. All right, now let's talk about another type of problem that you're going to see when you're studying inverse trigonometric functions. So you might run into something like this. Not might, let me edit that. You will, okay, absolutely run into something like this. And here is a problem that you need to know how to do. So evaluate cosine 300 degrees with no calculator. Believe me, you're going to have to do a lot of work with no calculator. And I can go on and on and on. There's much more about this and other things. I just want to give those of you that are watching this a good crash course with inverse trigonometric functions, but there is more variety of different type of problems that you need to practice. So again, if you want additional help from me, meanwhile, check out my pre-calculus course. That's where I really get into this stuff even in more depth. All right, so how do I do this? Well, I want to find the cosine of 300 degrees. So the first thing you need to do is you have to draw yourself a nice sketch of the situation, okay? And remember, we are going to start with that initial side, okay? And then we're going to go to a terminal side. All right, so here, 300 degrees, you're going to start and you're going to go counterclockwise. So this is 90 degrees, 180 degrees. I passed 270. So to get to 300 degrees, I have to go 30 degrees more past 270. So what you want to do is draw yourself a ray emanating out from here. And the idea is we need to build ourselves a reference triangle. Okay, remember, the reference triangle will always have the x-axis as part of that triangle. So it's going to be something like that, or it might be something like that. Okay, notice here, right, that I'm using the x-axis. So this guy, we're going to have to build a reference triangle like so. Okay, so if this is 30 degrees here, right, 270 to 300, what is this angle right there? Because that's what I'm going to need for this reference triangle. That's 60 degrees. Okay, so again, remember, we're using no calculator here. And let's continue on. All right, so here is the situation. I got my angle, okay, of course, my full 300 degrees. I'm looking at my reference triangle, okay, and if I find the answer of the 60 degrees, which is the reference angle inside that reference triangle, I will answer the question. Now, one thing that you absolutely must know, especially in trigonometry without using a calculator, you have to know special right triangles, okay? Those would include the 30, 60, 90, big time. Okay, this is used, you got to be like a master of this thing, okay? And the 45, 45, 45, 90, okay? And if you need additional help on this, I have other videos, I'm sure, on my channel, because I have like 1,000 videos. Of course, I teach all this again thoroughly in my pre-calculus course. But let's take a look at a 30, 60, 90 right triangle. I'm going to get to this here in a second because we have to understand the sides of it, because we're only given 300 degrees. We don't have any sides of the triangle, but you should already know that, okay? So here is what you want to focus in on 30, 60, 90. This is 30 up here, 60 here. So the shortest side is 1. The hypotenuse is always double the shortest side. So if this is 1, that is 2. And then that medium side is this side, which is 1 times the square root of 3, okay? So let me show you this because I'm going to be a nice guy here. Let's say I had this. Here is 60. Here is, that's a terrible, let me be a little bit clearer. Here's 60 degrees. This is 2, okay? So let's go ahead and get the rest of the sides here. So the hypotenuse would be double that, 4. And then this side is going to be whatever this is times the square root of 3, okay? Now I have all the lengths of my 30, 60, 90 right triangle. All right, so this is 60. Now we've got to be very careful here because we have to concentrate on the side. Remember, the x and y axis can be either positive or negative because 300 degrees has ended up in quadrant 4. 1, 2, 3, 4. Okay, this x right here is going to be positive 1. Remember, the hypotenuse is always positive, so that's 2. All right, we're just kind of using this. You have to really concentrate on this, and then this medium side is associated with this negative y axis right here, so this would be negative square root of 3. Okay, so once you've done all of that work, now we can go use our cosine or SOHCAHTOA. So cosine is the adjacent over the hypotenuse, and let's go ahead and answer this. So the cosine is 60 degrees, adjacent over the hypotenuse. Remember, I'm focusing on this. Its adjacent is 1, okay? And the hypotenuse is 2. So the cosine of 60 degrees is, whoops, whoa. Let me scoot back here. So the cosine of 60 degrees is 1/2, but the original question was, hey, what's the cosine of 300 degrees? It's the same, okay? So remember, if we find the reference angle,
It's as finding the answer to the actual question, the actual angle. So the cosine of 300 degrees is 1/2. And if you got that's right, and if you're like, yeah, I knew all this, I just wanted to check myself out, I must give you a happy face with a crazy 1983 Flock of Seagulls Mohawk with extra hairspray. If you don't know who Flock of Seagulls were, they were an awesome 80s band. But anyways, A plus and 100%. Nice work. And again, inverse trigonometric functions is like the foundation of studying more advanced trigonometry. It's used like almost everywhere. Okay, so you have to know this. So if you're struggling with it, because you're just starting out, all right, that's one thing. But if you are in a trigonometry class or pre-calculus, college algebra, something like that, where you're studying just beyond more basic trigonometric ratios, well, then, you're going to have to know this absolutely 100%. All right, so let's go ahead and wrap this up. If this video in some small way has helped you out, please consider smashing that like button. And if you're new to my YouTube channel, please consider subscribing. Again, I have, well, I've been on YouTube for over 10 years and I have over 1,000 plus videos. I'm posting content all the time. But of course, my best math help will be within my Math Help program. All right, so with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.